Hey, Science fam. We are going over the specific heat worksheet number 1 questions, and I believe you were assigned 11 through 14, and that's what we're going to go through today. Number 11, after going through our notes in that, why is it important to define a system versus the surroundings when talking about endo or exothermic? Well, you can do your best to answer that question, but let's do one of the examples from our notes. Let's say there's a bonfire, okay? So here's my fire. Nice, there's a fire pit. And then we're standing around the fire, okay? Now, endo and exothermic, there's two things going on, but depending on what we define as the system and the surroundings, will determine if we describe this as endo or exothermic. So first of all, let's call the system right now the people. So if the people are the system, are we feeling the heat from the fire? And if so, if we're feeling the heat, are we taking in that heat or giving off that heat? And since we're taking in that heat, that process would be considered endothermic. All right, but let's switch colors now. Let's say now the system instead is green. And let's say this fire is the system. All right, well, if the fire is the system, though, we do know the fire is still pushing out that heat. Since the fire is the system losing or gaining energy? And the answer is it's losing. It's losing heat. So if it's losing heat, that would be an exothermic process, right? And remember, if it's exo, that means our value for heat, the Q, is negative. And again, if it's endo, that means the value for Q is positive because we're gaining heat. But the system and surroundings determine whether it's endo or exothermic. So it can be either or depending on what we describe. So defining system and surroundings is super important. All right, think about that and then write your best. All right, for question 12, we are looking into just getting used to some of our units that we talked about with energy and heat. So we have an English muffin that was 100 food calories. Now remember, a food calorie is a capital C calorie. We want to know how many regular or science calories that would be considered. Well, let's quickly remember that one capital C food calorie is equal to 1,000 regular science calories. Okay, so if we have 100 food calories, let's write down what we have. And we want to get rid of food calories, we're going to need to divide by food calories on the bottom and put regular lowercase calories up on top. Remember, for every one food calorie, there is 1,000 little science calories. Now, the reason this works out, this is not an equation. We've been canceling out units for many, many, many weeks now. But because that cancels out and we're left with that, we can just do the problem of the number 100 times 1,000 divided by 1. And when you do 100 times 1,000, it's going to end up being 100,000 little calories. All right? So as far as conversions is concerned, we're just canceling out the units. All right? If we look at the next one, how many joules? So don't forget, joules is a form of energy unit. How many joules would that English muffin technically equal in energy? Okay, well, I know that according to my notes, there's 4.184 joules for every one science calorie. Okay, so if I know already that that English muffin is 100,000 of those little science calories, can I get rid of that little science calorie and convert it to joule? And the answer is yes, because I know for every one little science calorie, there's 4.184 joules. Now, why does this work out? Because this is not an equation. This is simply canceling out calories and setting equal to it the same amount in joules. So my answer will become in joules. Now, if I multiply that out, that 4184, I'm going to move my decimal 1, 2, 3, 4, 5 places. So that's 1, 2, 3, 4, 5. So it looks like 418,400 joules is how much energy is in an English muffin. That's actually 100 food calories. Okay? So we are just simply practicing conversions here. No big deal. Don't get overwhelmed. So how many calories do 3,000 joules equal? Notice it said calories and not food calories. So we're just talking about regular calories here, and we already know that there's 4.184 joules for every calorie. So let's do that. I'm going to take 3,000 joules. I am going to get rid of my joules by putting joules on the bottom. And up on top, I'm going to put calories. I know for every 1 calorie, there is 4.184 joules. And I'm going to double check, do joules cancel? I'm left with calories in my answer. So I know that's how that's going to be. Now I just need to do 3,000 times 1 divided by 4.184. Let me plug that in my calculator and let's see what we get. I plug that in and I end up getting about 717.02 calories. That's how much 3,000 joules is equal to. All right, let's try another one really quick. How many joules does 15,000 calories equal? Okay, so I have 15,000. Again, these are not food calories. These are regular calories. Otherwise, it would specify. If I want to get rid of regular calories and get into joules, excuse me, I need to use my conversion factor. And I know that 4.184 joules is equal to 1 calorie. You know that from your notes, if you did watch your notes. So for every 1 calorie, there's 4.184 joules. My calories cancel out. I'm left with joules in my answer. And I'm going to put that in my calculator to see what I ended up getting. It's going to be 15,000 times 4.184 divided by 1. I end up getting an answer of 62,760. My units are in joules. Okay, that's a lot. Remember though, little science calories are small, much smaller than a food calorie, and joules are even smaller than science calories. So keep that in mind. This is a large number, but that's normal. For number 15, the last question, we'll need to learn more about specific heat in order to answer that last question, number 15. So don't do that one just yet, unless we've already talked about and assigned 15 because we've learned about specific heat. All right, guys, take care and reach out with any questions that you have. Have a great one.